Hello everyone, today I will talk about data visualization by using D3JS platform, which is a JavaScript based framework for data visualization and data analytics. One of the advantages of this platform is that you can show the data interactively and you can just embed this visualization into your web-based platform like a website or other platforms that you have. So in order to access the instruction and data about this workshop, please go to our website, sites.google.com, g.clemson.edu, VizLab Home, and then here you could find several information about other workshops that we had, but particularly for this video, I will talk about D3JS or Introduction to Data Visualization with D3JS platform. So please click on Introduction to Data Visualization with D3JS. So in order to receive a certificate of completion of this workshop, please send your final visualization created based on the material in this workshop on Friday, July 3rd in the next week to me at my email address mentioned here at yusefid@clemson.edu. The outline of this workshop is that first I will introduce some basic information about what D3JS is and how it's useful for the data visualization, and also which development environment that we will use for scripting. Then we will move on to creating a simple bar chart based on the data that we have, and then we will add some interactive modules to this bar chart. For example, how we could zoom on this bar chart and have some interactivity that we could embed into the website. In the next section, we will work with data that we could create a scatter plots out of the data visualization. And then finally, we will create some interactions to creating animation and how we could have more interactive data visualization based on D3JS. Finally, we will use mapping or ArcGIS for embedding the data visualization into the map to showing, for example, the COVID-19 data set that we have across all the counties in the United States. So the only prerequisite for this workshop is to creating an account in the Observable website that I will introduce more information later on about how you could create a free account in the Observable website, which is an interactive environment to run JavaScript codes. And you will find some other information about how you could contact us if you have any question about this workshop or other workshops that we had. So in the first section, we will have some introduction and basic information about D3JS and its development environment. So please click here. As I said before, D3JS is a web-based platform created based on JavaScript and designed specifically for the data visualization, actually interactive data visualization. So basically, you could convert numerical tables into more meaningful plots, charts, map, etc. And it's useful because based on this data visualization, you could convey more descriptive message to the other people that about the story that you want to tell. As I said, the advantage of the D3JS is that you could have interactivity and you could embed easily this data visualization in your website. And in order to show this data visualization, how it's interactive embedded into the website, we have a simple bubble chart embedded in our website based on the example of borrowed from this notebook here. So you could see that you could just change the position of these circles and it just interactively change the underlying data for you. So it just user could interact with your visualization, so it's not just a static uh, picture or a screenshot that you take from your visualization. So it just brings more interactivity, and especially it could be embedded easily into your web platform that could be easily shared with other people across all the internet or the users of your website. So you need to create, in order to follow the materials in this workshop, you need to have a free account created in the Observable website. So please go to the observablehq.com. If you click here, it just opens the observablehq.com website. In order to create an account, click on sign in and create account, and just ask you if you have a GitHub account, Twitter, or Google. Certainly you have a Google account with your Clemson username, so you could just use your Clemson username. If you click continue with Google, it just asks which username that you want to use. As I said, I just use my Clemson Google account. And if you log in successfully, you should see this menu at the observable hq.com. So that's just the platform that we want to use for creating the notebooks, sharing the notebooks, and creating the visualization based on the material in this workshop. So as I said, you just go to the observablehq.com. I just go briefly over the steps that you need to do for creating a new account. Go to this website, observablehq.com, click on sign in, and then click on create account here, as I just showed you. So click on continue with Google. Again, I just showed you before how to click on that. And then just type a username for just whatever name that you want to use as your observable username. And then just click on set username. If your account successfully created, you should see this dashboard in the observable.com, observablehq.com. In order to follow the workshop materials, please download the United States COVID-19 dataset for day June 24, 2020 from this link, and also the COVID-19 dataset for the day April 20, 2020 from this link created here, and also finally downloading the breast cancer dataset from the University of Wisconsin could be downloaded from this link here. So that's the first part of our introduction to D3JS workshop, that you just learned what D3JS is and how you can create a free account in the observablehq.com to just create notebooks and create visualization for the rest of this workshop. Thank you. We will continue in the next videos for other parts of the workshop. Thank you. Here I will introduce the next section of our video for the D3JS workshop. Here we will learn how to create a simple bar chart. So please click here in our outline for the making a bar chart. In order to create a notebook or new notebook in the observable environment, you need to go to the notebook section of the observable website. Please make sure that you just logged in successfully and created your free account in the observablehq.com. Click on notebooks and click on new. It just creates a new notebook for you that you can just follow the instructions. The first step to just visualize the data is having the data actually uploaded in the development environment. In order to upload the file in the observable environment, you need to click here in the notebook actions, then choose the file attachments, and then choose the data that you want to use for the visualization. So you just click on upload here, and then choose the COVID-19 dataset for the state of South Carolina across different counties as its name, data-sc.csv, and then click on open. After successful upload, you should see the data-sc.csv file in the uploaded file as shown here. So you would have the data file shown here. So we have the file, but we need to actually load the D3.js modules in the observable environment because we want to use several functions and variables which are already available in the D3.js package. So in order to load D3.js in the observable environment, just type D3 equal to require D3 add 5. It just you need to click to insert a new cell and then type this command that just load all the functionalities of the D3.js into your notebook. In order to run this cell, just make sure you just click on this triangle here or use the shift return as it said here. So after successful loading of D3 package, you should see no error and it just loaded the object D3 for you like this. So you should see the result of your script. The first part is that we want to define several attributes of the bar chart. For example, the bar chart has a color that you want to use for it, the height of the plot that we want to have, and also what would be the margin of this plot from the top, right, bottom, and left. So we could define these all attributes as a string called steel blue, which is just the color of the bar chart that we want to create. Its height is chosen at 500. You can just change that whatever you want. And I just use this margin. So also you could change these margins based on your variables. But these are just the margins values that I choose for this data visualization. The next step, which is just the most important step in creating the visualization, is to load the data in an array successfully based on the file that we uploaded in the notebook. Fortunately, the D3.js just gave us a function that just could parse the CSV file or comma separated value files. So here you just use the D3.js. The CSV parse is the name of the function that we want to use for parsing the CSV file. It just says use the attachment file that we uploaded in the notebook as called data-sc.csv, and we just put the task of finding the type or the format of the data to the D3.js itself to just find which format that we used for this file, because otherwise you need to define which columns that you have in your data file and what's the name of the columns. But if you use the autotype or d3.autotype, it just automatically finds the format of your file. So it's just easier for the bigger file that you have several columns that you don't remember exactly which column is the first or what's the name of the column. So it just automatically finds the name of the columns. I just sort them based on the sequence that you just put in the file. In the next step, we want to define the scale and axis for our bar chart, because we want to know what's the margin or what's the position of the bars based on different data types that we have, and also these bar charts, how it's scaled across the X and Y axis, that you could find the definition of the X and Y scale here. And also we define the X and Y axis to create this bar chart. The X axis, it just use the name of the counties available in the COVID-19 data set of the South Carolina. Basically, we want to create a bar chart based on the number of the cases of the COVID-19 in each county. And in the x-axis, you have the name of the counties, but in the y-axis, you have the number of the cases. So here you choose the name of the county, which is shown as the data I.county. We just extract the name of the counties for you. And here you just have the y-axis, which is just the data.cases, which just gives you the number of the cases in each county that you have in the x-axis. Finally, you could just load SVG, which just gives you an empty SVG image based on the width and height that you defined. Basically, you say here that I just want to fill it with the color that I defined based on the steel blue color. You can just change the color, but that's just the color that we chose for creating the visualization here. It's a rectangular image, and you load the data that we just loaded from the COVID-19 data set for the different counties that we had. And we say that the x-axis is just the x-axis that we defined here. And also the y-axis is the number of the cases. And we have the height and width of each bar chart, which just depends on the number of the cases that we have. Finally, you should see the bar chart created here. Note that this is actually the actual visualization embedded in this website, so it's just not a screenshot from the visualization. Here you see the name of the different counties, for example, York, Williamsburg, Richland, or other across the South Carolina, and in the y-axis you see the number of the cases in each county. Note that this bar chart is not really interactive right now, despite the fact it's the actual visualization. It's not a screenshot, but you don't have any interactivity here. And also note that it seems the name of the counties are just just based on the sequence that we had in the file. But more logically, we want to sort the counties based on the number of the cases, for example, from the high to low number of the cases. But in the next section, we will find out how we could make this bar chart more interactively. For example, how we could add a zoom interaction to the bar chart, that you could just zoom in different part of this bar chart. And also we sort this data set from high to low number, or in the descending sequence based on the number of the cases. In order to access the final notebook created in the Observable HQ, you can just click on this link. It just gives you the same bar chart created here. That it just shows you all the steps that you need to have for creating this bar chart. So it just summarizes all the steps that we had. We went through the material in this section. In the next section, we will find out how we could make it more interactive and also sort the data. Thank you so much. In this section, actually, in the previous section, we learned how to create a bar chart. But in this section, we will learn how to add a zoom interaction and also sorting the data set in descending order in order to make the visualization more interactive and more beautiful and more informative in terms of conveying a more important message to the user. So For this section material, just click on the working with zoom interaction and sorting the data set. If you click here, actually the only things which is different is here is that we want to make the axes that we'll learn for the X and Y axes that we had in the previous section, make those axes interactive in terms of the zooming functionality, and also change the data to sort it. So those are just the two differences that we have in comparison to the previous section. So here you need to change the scales for the X and Y axis. Still, in the X axis you have the name of the counties, and also in the Y axis you have the number of the cases, but note that we use the sorted data that we will find out how we sort the data in the just a couple of minutes. And also in terms of the interactivity, we need to define a zooming interaction. That's just the main function that just creates the interaction of zooming. When you zoom in the bar chart, it just show you more details. So basically, you want to have the margins or the width and height of the bar chart interactively changing or dynamically changing based on how you zoom on the plot chart. Then you scale your plot based on a different scale extent that you have. Then it just zoom the X and Y axis, and then adapt actually the name of the counties and name number of the cases based on the zoomed area. So that's just the function that just creates this zooming functionality. And we embed or we call this zooming functionality besides the attributes that we had for the width and height for the image that we created. Actually, it just gives the zooming interaction or interactivity to the bar chart that we had before in the previous section. And also note that we use the sorted data, but how we could create this sorted data. Actually, we learn how to load the CSV file into the D3JS or the observable platform. But in order to sort it, we need to use the sort function. The sort function takes two input. First, you need to have a tuple of A and B. Basically, you want to say, okay, I have the before sorting and after sorting, it's A and B, and you want to just sort it in the descending order. With just the descending function from the D3JS package just gives you that functionality to sort the data in the descending order. But if you want to sort it in the ascending order, you need to just change this descending to the ascending. And then finally, similar to the previous one, we have this bar chart, but note that in comparison to the previous chart that we have, the data is sorted from the high to low number of cases. And also here, you can just zoom into the bar chart and also move it to see different regions. So it's just more interactive, and it's not, as I said, it's not just a static screenshot of your visualization. So it's just embedded in this website, and you could have more interaction to see all the aspects of this visualization. For example, find which counties have higher number of the cases. Especially, it's much easier because we just sorted this data set. So that just brings more interaction and interactivity, and that's just a strength of the D3JS package. Again, similar to the previous one, that we had the notebook that just gives you all the steps. You need to just click here. That just gives you the notebook that just has all the steps that you need to follow to create this visualization. And again, also you have the interactivity in the notebook, of course. And then you could find all the functions that we defined here. So that just brings more reproducibility based on this notebook, and you can just follow all the steps and find all the functions here. Thank you. In this section, we will learn how to create a scatter plots. In the previous section, we just worked with the COVID-19 dataset in the South Carolina in the different counties that we had. But here we will work with the breast cancer dataset that we could create a scatter plot, basically plot various variables versus each other, and also color the points of this scatter plot based on the two different groups of normal and cancerous cells that we have. So in order to see the workshop materials, click on learning how to create a scatter plots. As I said, you need to load or upload the breast cancer data.csv that you downloaded in the first section of these videos into your notebook. And then in comparison to the previous charts or bar charts that we had, here you need to change the X and Y axis, because in comparison to the previous ones that we had the bar chart, here we want to create the scatter plots. So the scatter plots are created based on points, or just a scatter number of points that we have in a chart. So the x-axis is defined like this, and the y-axis also is defined here. Note that we give the number of the variables that we want to use for the scatter plot later on in a column array that we want to use for the name of the variables. But here we just define the generic format of the x and y axis and how it's defined based on these columns length, for example, the number of the variables that we want to use for the visualization. Here we use 4 variables, so we would have a matrix of the scatter plots, 4x4 matrix of the scatter plots finally, and we just plot each of these variables versus other one. So we would have 16 scatter plots at the end. The scales also are defined like this based on the size and padding that we defined. And also we have an interaction here in our scatter plot to just choose some of the points interactively. So you just create a dashboard for you. You can just choose some of the points and see how those points are located in the other scatter plots. Basically you have 16 scatter plots, but in each of them, if you choose some of the points in the other plots, also those points will be highlighted. So for example, if you want to see the points that have high values of some variables, you would find out those points have, for example, lower values in other scatter plots. So that just brings more interactivity into your visualization. So this brush is the main interaction function that we define here. You can just go through it in the notebook or in the workshop material here. And finally, we would have this visualization of a scatter plot. As I said, we chose to plot the mean radius, mean perimeter, mean smoothness, and mean concavity. But you could just change the name of these variables in the notebook and have more visualization based on different variables. Here, the color, the blue and the orange, shows 2 different cases that we have for the points which are the normal and cancerous cells. And here, if we interactively choose some of the points, those corresponding points are also selected in other scatter plots that we have. So it just brings more interactivity when you want to choose some of the points and see how those points are located in other scatter plots. So finally I go to the notebook here. Similar to the first one, we just load the Free.js package. Make sure that you just uploaded the file. If you click here and see the attachment, we have the breast cancer data.csv. And make sure you loaded the Free.js. You have some attributes for the padding, size of the bar chart, its width, and other name of the columns that or the name of the variables that we use for the scatter plots. Then similar to the previous one, we just loaded the data, the breast cancer data that we just uploaded here. It just loaded into a variable named data based on the CSV parse function. Then we define the X and Y axis and also the scale X and Y scales. Then we define the brush function here to just have interactivity over the scatter plots. And finally, we have the scatter plot itself. Similar to the previous bar charts that we have, we create a SVG with just the empty image based on the widths and heights that you created. Then you have some circles that you want to use for the scatter plots. You define the X and Y axis, and also you just have that brush transformation or brush interactivity. And finally, you just plot the data here. So that's the final function that just plots this scatter plot for us. So here also you have the interaction. You could select some of the points and see how those points are located in different bar charts. But note that you can change this name of the variables: mean radius, mean perimeter, mean smoothness, and mean concavity, which I just encourage you to change that and see how the scatter plot would change after changing the name of the variable. So it just brings you more insight about what's inside the data set. So that's the final notebook which is shared with you that you can use or follow for instruction of the material in this section for creating the scatter plots. Thank you. Hi everyone, in this section finally we would find out how to create animation interaction. Basically dynamically we would have interaction with the visualization. Again, we will use the scatter plots for synthetic data that we just created based on some random numbers, and how we see how we could use the zoom interaction for creating an animation that just zoom into some areas of the data for the visualization and it just zoom back and use other regions. So it just gives you a feeling of the animation and how we could interact with the visualization. So if you click here in the developing events and simple interactions such as clicks event and creating animation, the only thing that we changed in comparison to the previous one that we created the scatter plot is that we need to have a transforms, that we just use the zooming interaction for zooming and zooming out interactively to create a animation. This transform function is defined here. So basically you want to tell the transformation that which parts that you want to zoom, so it just takes the parts based on the clustering of the data. The x0, x1, y1, and y0 are the extents of the data in each region. And then we zoom in those regions and then we zoom back and we just repeat this transformation to create an animation, or just gives the user feeling that the interaction is like the animation. As I said, we use synthesized random data that we just created based on some random numbers here in comparison to the previous data that we just use some real application data here in order to show how this animation interactivities work. We just use with some synthetic data. And Here you would find these clusters, but in order to see the interactivity, you need to click on this notebook here. So you see that it just zoom out in different clusters that we have. Also, it just show you the overview of 3 clusters created based on these random numbers, and it just zooms on the cluster 0, 1, and 2 interactively. So it just gives you the feeling of an animation. It just show you the overview and zoom on each clusters. So it's a good homework for you to just use the breast cancer dataset instead of just this synthetic data created based on random numbers. I just go over the steps that we used. So similar to the previous one, for the bar charts that we had the zoom interaction, we want to have the zoom interaction, but the transformation that the function of the transform we define, it just makes this zoom interaction uh, bounded or similar to the animation. So you just zoom in and zoom out in different regions. Other steps is similar to the previous scatter plots that we had, and it just update this transform function, update the bar chart or this scatter plot. So it just zoom in, zoom out sequentially for different clusters. Here we define, as I said, a synthetic data based on the random numbers for 3 different clusters. And then we define the transform function that just does the job for zooming in and zooming out and updating the scatter plot. And similar to the previous one, we have the x, y scales, and also the x and y axis, and also the height, width, heights, widths, and other attributes that we define. So that's just a notebook that you want to follow for uh, creating an animation based on these different clusters that we have here. Thank you. Everyone, in this section, finally I will show you how to create a mapping visualization based on the COVID-19 data set across all the counties in the United States for day June 24th, 2020. If you click in the outline here, creating web maps and combine it with data visualization, click here. Here we want to use this US COVID-19.csv that you downloaded in the first section of this video series. And also you need to have a file for having the name and the shape of the counties in the map. Here it's just the final visualization of this map, and different color shows the number of the cases of the COVID-19 across different counties from 0 to 1,000. Note that it's just not a screenshot and it's just an interactive map embedded in this website. For example, you could find out that it's actually interactive by going through in each county, just show you the name of the county, name of the state, and also the name of the number of the cases. So it's not just a static screenshot. Again, as I said, it's interactive visualization embedded in this website. So you could create a colorful map and just uh, show you the data based on different colors in this map. It's just more interactive and more meaningful to convey the message. So I would go briefly over the steps that we have. It's similar to the previous one, but for the maps we have some other configurations. So you would find the final notebook here if you go to the observablehq.com and click here. So in order to create the map, again, similar to the previous one, you create a SVG, and based on the different heights and widths that you have, I defined the shape of the counties based on the files that I had. If you look at the file attachments here, I have two files here, uscovid19.csv and counties.albers.json. You need to download this file. If you don't have, just go to this notebook and click on download and then upload it in your notebook that you want to create from scratch. So note that not necessarily it would be named @1 because I had another one, so I just named @1, but you need to download this file here. You downloaded the other file, uscovid19.csv, at the beginning of this workshop, but the other file also need to be downloaded from here. So that just contains the shape and the position of the counties. And then you take the data based on the different IDs of the counties, because as you know, each county has a FIPS ID. It's a unique ID that defines each county in the United States. And we just match this data for the number of the cases of the COVID-19 and the shape and the position of the counties based on this FIPS ID. Here I use the CSV parse function similar to the previous one for loading the US COVID-19 CSV file. And as I said, I need to have the FIPS ID and the number of the cases. And also I define just the title to show you what's this data set. So it's just the COVID-19 data set in the US at the date June 24. You define your color sequential with it's just this bar chart. I just choose to use the turbo color map. You can just change that. And also the range that I just use for my color is from 0 to 1,000 number of the cases. And then I just load that file for the shape and the position of the counties. And then I just match that with the ID that I have for data for the COVID-19. And finally, it would just create this map and just colored by the number of the cases. So it's just a colorful plot that you want to create. And note that again, it's not a static screenshot, and you can just interactively see the number of the cases, the name of the county, and also the name of the state. So you can just wait on each section of this map and see which section belongs to which section of this map. So that's just interactive, and it's just a good practice to create a similar map, for example, for the number of deaths instead of number of the cases. So that just brings more interactivity to your visualization. And finally, it's embedded and it's easy to share with other people through the web-based platforms like this. Thank you so much for your attention to our workshops.